A surprising number of young adults aged 19 to 25 still live in their parents' homes. A random sample from the National Institutes of Health included 2253 men and 2629 women in this age group. The survey found that 986 of the men and 923 of the women lived with their parents. So part A is constructed, interpret a 99% confidence interval for the difference in population proportions, men minus women. And part B, does your interval from part A give convincing evidence of a difference between the population proportions? All right. So for part A, we're going to construct that 99% confidence interval. So our state is our parameters of interest are, so P1 is going to be the actual proportion of young men who live at home, and P2 is the actual proportion of young women who live at home. And the goal is we want to estimate the difference of P1 minus P2 at a 99% confidence level. So, since we're dealing with two proportions, we should do a two-sample z-interval for P1 minus P2 if the conditions are met. So, the random condition, of course, both samples were selected randomly. Now the normal, okay? So this is going to be N1 times P hat 1, which remember N1 was 2253, and P hat 1 was 986 of men. Okay, so 986 out of that 2253. Let me do a better job with that 3. Okay, which of course is equal to 986, which is bigger than or equal to 10. So N1 times times 1 minus, right? 1 minus P1 hat is equal to 2253 times 1267 over 2253. That's equal to 1267, which is bigger than or equal to 10. So now the next one, N2 times P2 hat is equal to, so in this case it was 2629. 2629 times, and then it was 923 over that 2629, which is equal to 923, which is bigger than or equal to 10. And then last one to check, N2 times 1 minus P2 hat, which is equal to 2629 times 1706 divided by 2629. And that's, of course, equal to 1706, which is bigger than or equal to 10. So the normal condition is satisfied. Now the independent condition. So we know that N1 is equal to the population of young men, and N2 is equal to the population of young women. Okay, maybe I'll scoot this down a little bit. Right. Okay, so remember it has to be N1 has to be less than or equal to 1/10 of capital N1, and N2 has to be less than or equal to 1/10 of capital N2. And I think it's safe to say, remember N1, the number in the first sample space was 2253, and that's less than or equal to 1/10 of all young men, right? And for the next one, it was 2629. Same thing, that's less than or equal to 1/10 of all young women. So our three conditions are met. So let's go ahead and do the next part. All right, so N1, remember, is equal to 2253, and P1 hat was equal to 986 over 2253, which gets to 0.438, and then N2 was equal to 2629, and P2 hat was equal to 923 over 2629, and that will give us 0.351. So our 99% confidence interval, that's going to be 1 minus 0.99 over 2, which is equal to 0.005. All right, so let's go ahead and get to our table. Okay, so here's our value, 0.0051 and 0.0049. So it should be 2.575, right? 2.575. So our critical value, so negative z, is equal to negative 2.575. And over here, our positive is going to be 2.575. All right. So let's go ahead and start our confidence interval. So it's going to be, scoot down, p1 hat, p1 hat minus p2 hat plus or minus z star times the square root of, so that's going to be p1 hat times 1 minus p1 hat over n1 plus p2 hat times 1 minus p2 hat over n2. And let's plug in these values. So that's going to be 0.438 minus 0.351 plus or minus 2.575 times the square root of 0.438 times 0.562 over 2257 plus, and then this is 0.351 times 0.649 all over 2629. This will go to 0.087 plus or minus 0.036, which gives us the interval 0.051 and 0.123. So we are 99% confident that the interval, so the interval that we just calculated, captures the true difference in proportions of young men and young women who live at home. And of course, this suggests that between 5.1% and 12.3% more young men than women live at home, right? Based off of our interval and those proportions we're giving from our sample, right? Now remember, part B was asking, does this interval from part A give convincing evidence of a difference between the population's proportions? Well, since the interval does not contain 0, there is convincing evidence that the two proportions are not the same, right? Because if 0 was in the interval, then there could be a chance to where P1, so yeah, the proportion of young men minus the proportion of young women would be 0. That would mean that those two proportions could be the same, but 0 wasn't in the interval, right? So it does give convincing evidence that the two proportions are different.